Architecturally, Docker has three main parts. The first part is a client. When we are sending a command line request to a Docker, first where that request ends up is in the client. So for example, let's say that in this case we have a Docker build, Docker pull, and the Docker run. And when we are sending that command, so what happens is the client receives those requests, and the client sends the HTTP request to another part of the Docker, which is a daemon. Daemon is the main part of the Docker. It's a brain of the Docker. So what it does is it runs containers, it builds in images, and also it manages volumes, networks, and the registries. And another part that we have in the main architecture of a Docker is a registry. So in the registry, we are storing an images. So for example, in this case, let's say we are storing two images, right? We are storing images for the Nginx and for the Redis. So we can use a Docker pull command to pull that image into the daemon and run in the container. Let's take a look at the interaction between the Docker and the operating system. So Docker doesn't emulate an entire operating system like a virtual machine does. Instead, it uses Linux kernel feature such as namespaces to isolate processes, file systems, users, and the networks between containers. Another one is the control groups. Control groups limit and monitor resource usage like CPU and the memory. And also we have a union file system. For example, overlay 2, it's for layering multiple images to efficiently build containers. So that's for Linux, right? So main operating system that Docker uses is Linux. So, but how about the Windows and the Mac? Since those systems, meaning that the Windows and the Mac, they don't use Linux kernel directly, Docker Desktop runs a lightweight version of the Linux under the hood. So even on Mac or Windows, containers are still running inside Linux. So to summarize Linux, containers directly use kernel, but in case of the Mac and the Windows, what happens is that the Docker desktop, we install first Docker desktop, right, to run the Docker, it uses a tiny Linux virtual machine, and the containers using the kernel of that Linux virtual machine in order to run. Let's in the example of the Mac to see that how the container interacts with the Linux virtual machine's kernel. So for that, let's run this container, and here what we do is we are running an Ubuntu container, and we have a shell access to the Ubuntu container. And now let's see that what we have inside of that Ubuntu container, right? So let's see some details of the Ubuntu. So we have Ubuntu name, Ubuntu version, and all other details. But what we don't have here is we don't have information about the kernel. The reason is that this Ubuntu doesn't have a kernel because it shares the same kernel as the desktop Docker Linux virtual machines kernel. So they are sharing the same kernel. So to verify that, let's run a uname, and so as you can see here, this kernel Linux kit, it belongs to it's a Linux virtual machine. It's a Linux virtual machine that is running on top of the desktop Docker. So this kernel is sharing the same kernel with the desktop Docker. So another thing that what we can do is let's run and see that what processes we have inside of this container, right? Let's run and let's see that how many processes we have inside of this container. In the Ubuntu container, we have only two processes, right? So two processes. We have a bash the bash process that we have started, and also the PS to showing that the all processes that we have just started. So these two processes we have only these two processes we have inside of this container. So to summarize that, we can say that the containers are just the regular Linux processes managed by the Docker daemon. So now let's go back and see that to summarize our knowledge. So what we have here is we can say that for the Windows and Mac, we have for example for Mac, let's say, right, we have a Mac OS, and the Mac OS is on top of the Mac OS, we are running a Docker desktop, and the Docker desktop we are running a small version of the Linux virtual system, right, Linux kit, and the Linux kit is is serving kernel of the Linux kit is shared by all other containers. So let's say that we are running 5, 10, 500 containers. All those containers are sharing the same kernel of that Linux virtual machine. To summarize, what we have is the container use their own user space, Ubuntu file system. Containers do not bring their own kernel, and the Docker uses the host operating system kernel, such as Linux Kit in our case, right? And on the macOS and the Windows, Docker must run on a small Linux virtual machine. And this is why the containers start instantly, meaning that they don't take as much time as as the virtual machines, because from the perspective of the Linux, it's just another process.